Turbofan Aerospike engine, spacecraft propulsion systems from atmosphere to space. This invention relates to a zero-carbon turbofan aerospace engine for removing fossil fuels from present jet engines. Introduction. Present aerospace engines use carbon-based fuels that produce greenhouse gases, which increase the carbon in the atmosphere, leading to global warming. Greenhouse gases trap the heat of the sun in the atmosphere and subsequently raise the global temperature, adversely affecting the climate globally. The history of the Aerospike originates in the 1950s by Rocketdyne. The exhaust is more efficient than the traditional bell designed for a particular atmospheric pressure and hence the altitude. At low altitude, there is high atmospheric pressure. The bell-shaped rocket exhaust is small. At high altitude, there is low atmospheric pressure, approaching vacuum. The bell-shaped rocket exhaust is large. The Aerospike exhaust gas is shaped by the external air pressure. The Aerospike has many advantages. However, the Aerospike has problems of excessive temperatures on the spike, where the exhaust makes contact with the spike.
Statement of invention. To overcome air pollution and enable a zero-carbon flight from the present jet engines, the present invention proposes a turbofan aerospike engine comprising a plurality of radially mounted, variably hinged inlet flaps. 1. Plurality of radially adjustable curved surface. 2. Wherein the curvature is of said adjustable curve, surface is adjusted. In addition, the aperture of the said inlet flap 1 by computational judgment. 4. Means using data from at least one airflow speed sensor. 3. This cooperative arrangement will regulate and increase the air mass flow rate in the bypass duct of the turbofan aerospike engine. Bleed air from the low-pressure compressor, 5, is guided by ducting. 6. Means is used in cooling the outer combustion cans of the aerospike combustor. 13. Bleed air is guided by ducting, 7, to an air-gas accumulator. 8. At least one air cooling. 9. Means is used to reduce the volume of the said air-gas accumulator. 8. At least one airflow regulator. 10. At least one air supply ducting. 11. In order to supply pressurized air to the at least one external aerospike. 24. External to the turbofan, preferably wing-mounted. Internal said aerospike combustor, 13, is located in the combustion chamber of a turbofan engine, such that the internal stagnation pressure is sufficiently high such that the exhaust gas from the aerospike is maintained within and the said aerospike combustor, 13, casing without touching the container. High stagnation pressure compressor air supplied into the combustor air tube, 14, and circulates clockwise or anti-clockwise within the aerospike combustion chamber. High pressure compressor air supplied into the cooling air tube, 15, and exits through the cooling apertures, 16, in the spike and accelerated over the aperture curved surface, 17, towards the latter end. Vortex generators, 18, enable a boundary layer between the hot exhaust gas from the aerospike and the exiting gas from the said cooling apertures, 16, which is supplied by the said cooling air tube, 15. In addition, guide fins, 19, guide the airflow and enable conduction/convection cooling. The generator 12 is powered by the rotating shaft of the turbofan aerospike engine, supplies electrical power to the brushless electric motor. 20. Turns the fuel turbo pump, 21, which pumps the carbon-free fuel to the aerospike combustion chamber. 18, and circulates clockwise or anti-clockwise within the Aerospike combustion chamber. The carbon-free fuel supplied by the turbopump, 21, and compressed air is supplied by the high-pressure compressor combustor air tube, 14, and mixed in the circulation and ignited by the combustion chamber igniter, 22. At sufficient high altitude and speed, the propulsion system may be changed to a ramjet, 23, which compressed air guided by said ducting 7 to said air gas accumulator, 8. At least one said air cooling, 9. Means is used to reduce the volume of the air accumulator. At least one said airflow regulator, 10. At least one said air supply ducting, 11. In order to supply pressurized air to the at least one said external aerospike, 24. External to the turbofan, preferably wing-mounted.
Hypersonic is where I wanna be. Hypersonic just for you and me. Hypersonic, we travel near and far. Hypersonic, we shine just like a star. Cruising down the midnight sky, we fly and ride so high, touching stars way up above, chasing dreams and cosmic love. Where we go, no one knows. Untold stories will unfold. Some are danger, some are gold. Solar system we behold. Hypersonic lights up the night. Hypersonic, our hearts take flight. Hypersonic, beyond the blue. Hypersonic, our dreams come true. Cruising through the midnight sky, we fly and ride so high, touching stars way up above, chasing dreams and cosmic love. Where we go, no one knows. Untold stories will unfold. Some are danger, some are gold. Solar system we behold.
Hypersonic, I have so much love for you. Hypersonic, flying faster than the speed of light. Hypersonic, galaxies as far as forever. Hypersonic, we endeavor together forever.
Cruising through the midnight sky, we fly and ride so high, touching stars way up above, chasing dreams and cosmic love. Where we go, no one knows. Untold stories will unfold. Some are danger, some are gold. Solar system we behold. Hypersonic, our dreams live on and on in the vacuum of space. Hypersonic, limitless boundaries, dancing with infinite reality. Hypersonic, waterfalls of things within dreams. Hypersonic, interdimensional with hypersonic. Cruising to the midnight sky, we fly and ride so high, touching stars way up above, chasing dreams and cosmic love. Where we go, no one knows. Untold stories will unfold. Some are danger, some are gold. Solar system we behold. Hypersonic, 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 Hypersonic. Hypersonic, I have so much love for you. Some are danger, some are gold. Solar system we behold.